So hello guys, today we're going to tackle about the mean, variance, and standard deviation of a discrete probability distribution. So let's start. So we're going to first determine the mean. So mean is an average or central value of a given set of numbers. It's represented by this formula. Mean is equal to the sum of x times p of x. So let's try solving the value of the mean in this given situation. In an nth class, the teacher observed the number of students attending per day, which represented with a random variable x, and came up with the following probability distribution. So, the number of students attending per day is represented by this random variable x, and this column represented the probability. So in order to find the mean, we're going to multiply the random variable to the probability, and we're going to subtract all of those products. So 7 times 0.1 equals 0.7, and so on. After multiplying those, we're going to get all of those products and get the sum of those. So 0.7 plus 2 plus 6 plus 2.2 plus 1.3 equals 12.2. So our mean is 12.2. So next is variance. So variance is the average of the square distances from the mean. So variance is represented by this formula. Variance is equal to the sum of square root of x minus mean times p of x. So let's go. So in the given situation lately, we have determined the value of the mean. Now we're going to determine the value of the variance. So step 1 in determining the value of variance is to find the mean. So we're done in finding the value of the mean, so we're going to follow the step 2. So step 2 is to subtract the mean from the x. So we're going to subtract the mean from the random variable. It will be represented by x minus mean. So we're going to minus 7 to 12.2. 12.2 came from the value of the mean, and 7 came from the value of a random variable. So we're going to subtract all of these in this column. So after getting the difference, we're going to proceed to step 3. So step 3 is to square the results from step 2. So we're going to square all the differences that we get in subtracting the mean from the random variable. So we're going to square it. Negative 5.2 squared, so equals to 27.04. We're just going to do the same from the other row. We'll proceed to step 4. Multiply the results from step 3 to p of x. So after getting the results in squaring the differences that we get from subtracting the mean from the random variable, we're going to multiply it to the p of x, or the probability. So 27.04 that we get from squaring this value, and times 0.1 came from the probability, equals 2.704, and so on. Next is step 5. Add all the results from step 4. So after multiplying the results that we get from squaring the differences that we get from subtracting the mean from random variable, we're going to add all of those. So 2.704 plus 0.968 plus 3.136 plus 0.288 plus 0.064 equals 7.16. And now we have the value of the variance, which is 7.16. Next is standard deviation. Standard deviation is just the square root of the variance. So standard deviation is represented by this formula. So standard deviation is equal to the square root of the variance. So let's try getting the standard deviation from the given situation. So we're done getting the value of the variance and the mean, so we'll now proceed in getting the value of standard deviation. So by getting the square root of the variance, it will give you the value of standard deviation. So we're just going to square the value of the variance that we get earlier. So standard deviations equals the square root of 7.16, which is the value of variance, equals standard deviation equals 2.68. So we're done. The final answer that we get is mean is equal to 12.2, variance that is equal to 7.16, and standard deviation that is equal to 2.68. That's a lot of process, isn't it? But next is we're going to tackle the alternative formula that we can use in getting the variance. So, alternative formula in finding the variance. So, step 1 is to find the mean. So, we're done in getting those because it's always the step first in solving a situation. So, mean is equals to 12.2. Step 2 is square the mean and save the value for later. So, we're going to square the value of mean and we're going to save the value later. So, squared mean is equal to 12.2 squared. And mean is equal to 148.84. So we're just going to save that value for later. So next is get the square of x and multiply it to p of x. So we're just going to square the value from random variables and we're going to multiply it from the probability. So 7 squared is equal to 49. 7 came from this column or from the random variable. And after that, we're going to multiply it to p of x, which is 0.1. That came from the probability. So 7 squared equals 49 and 49.2.1 equals 4.9. We're just going to do the same from the others. So next, step 4 is to get the sum of the products from step 3. So after multiplying the square of random variable to the probability is we're going to add all of those products. So 4.9 plus 20 plus 90 plus 24.2 plus 6.9 equals 1.6. So step 5 is to subtract the square of mean from the result in step 4. So earlier we get the square root of mean, which is 148.84, and we're going to subtract it from the value that we get from step 4. So 156 that we get from the value of step 4 and 1 minus 148.84, which came from the square of mean. So 156 minus 148.84 equals 7.16, and the variance is equal to 7.16. The process is short, and I recommend it for you to use this process because the value is still the same. So next is finding the standard deviation. It's just the same process. We're just going to square the value of the variance and we're going to get the value of the standard deviation. So standard deviation is equal to the square root of 7.16 and standard deviation is equal to 2.68. So that's all, guys. I hope you learned something about getting the value of mean, standard deviation, and variance in a discrete probability distribution. So thank you for listening, and I hope you can use these lessons in the future and for your other lessons. So thank you.
Our topic will be the normal curve and its properties. I am Daniel Diane Villanueva and I will be discussing this topic. So first, what is the normal distribution? It is a continuous distribution and also referred to as the Gaussian distribution. It is to honor the mathematician Carl Friedrich Gauss, who derived the equation. It can also be called the bell curve. The normal distribution is characterized by two parameters, the mean, which is written as mu, and the standard deviation as sigma. Now, the question is, what are the properties of the normal distribution? We have the first one, which is the curve has a single peak, which means the distribution is unimodal. Unimodal is when there's only a single highest value or mode shown. Second property, a normal distribution has a center value, which is the mean mu, and we can also see that beside the zero, which is the mean, we have the standard deviation of which is 1 and continuously extends. Now we have the third property. A normal distribution is symmetrical at the mean. It shows that when we cut a normal distribution at the center, we will get the exact half of the graph. If we look at it, it looks like a reflection. For the fourth property, a normal curve extends infinitely to the left and right sides away from the center. As I mentioned earlier, a normal distribution is continuous, which means that it doesn't end. Fifth, the curve never touches or crosses the x-axis. No matter how close the curve is from the x-axis, it will never touch it. The sixth property, for a normal distribution, the mean, median, and mode are equal. And for the last property, the total area under the curve is always equal to 1 or 100%. Now, let's proceed to the empirical rule or the 68, 95, 99.7 rule. It says that within one standard deviation away from the center, it is equal to 68%. For two standard deviations away from the center, it will be equal to 95%. And 3 standard deviations away from the center, it will always be equal to 99.7%. This helps us to anticipate the probable outcomes in a normal distribution. With the 68, 95, 99.7 rule, we can easily tell the probability we are finding. Based on the picture given, we can see that the areas of the normal distribution are already stated, which can be helpful as we go along with the next topic. And that's the end of this discussion. I hope you learned something from me. Thank you.
Today, my topic will be converting a normal distribution to a standard normal distribution and vice versa. I am Michael DeFeo, one of the contributors in this project. First, what is a standard normal distribution? Standard normal distribution is also known as z-distribution or specialized normal distribution wherein the mean is always equals to 0 and the standard deviation is equals to 1. It maintains the shape of a normal distribution bell-shaped. The z-score. Z-score specifies precise location of x value within a distribution. It is one number that establishes the relationship between the score, the mean, and the standard deviation. The numerical value specifies the distance from the mean by counting the number of standard deviations. The sign positive or negative indicates whether the score is above mean or below the mean. Converting a normal distribution to a standard distribution. When converting a normal distribution to a standard normal distribution, we use the z-score formula. Z is equals to x minus mean divided by standard deviation, wherein x is the value of a random variable we are converting. Mean mu is the mean of the normal distribution of x. Standard deviation is the standard deviation of a normal distribution. Example: the random variable x is normally distributed with a mean of 85 and a standard deviation of 5. Find the z-score corresponding to x is equals to 9. Solution. We simply substitute the given values in the formula for z. From the given, we have mean mu 85, standard deviation of 5. The value we want to convert is x is equals to 90. Z is equals to x minus mean divided by standard deviation. Z is equals to 90 minus 85 divided by 5 will give you 5 over 5 or 1. Thus, x is equals to 90 converts to a z-score of 1 when the original distribution has the mean of 85 and a standard deviation of 5. As shown, z-score can be positive or negative or 0. But what if the given are just the z-score, the mean mu, and the standard deviation, but not the value of a random variable x? In this case, we use the raw score formula. X is equals to z multiplied by the standard deviation plus mean, wherein z is the value of the standard random variable we are converting. Mean mu is the mean of the normal distribution of x. Standard deviation is the standard deviation of the normal distribution. Example: for a distribution with a mean 60 and the standard deviation of 5, what raw score of x corresponds to the z-score of negative 2.00? Solution. We simply substitute the given values in the formula for the raw score. From the given, we have mean 60, standard deviation of 5, and the value we want to convert, which is z is equals to negative 2. X is equals to negative 2 multiplied by 5 plus 60 will give you negative 10 plus 60. That leads you to the raw score of 50. Thus, z is equals to negative 2 converts the raw score of 50 when the original distribution has a mean of 60 and the standard deviation of 5. And that is how you convert a normal distribution to a standard normal distribution and vice versa. Thank you!
A variable is a quantity whose value changes. A discrete variable is a variable whose value is obtained by counting. A continuous variable is a variable whose value is obtained by measuring. Continuous variable is defined as a variable which can take an uncountable set of values or infinite set of values. For instance, if a variable over an array range of the real numbers is continuous, then it can take any value in that range. In continuous optimization problems, different techniques of calculus are often used in which the variables are continuous. Also, the probability distribution of continuous variables can be stated in expression of probability density functions in statistical theory. A variable can be defined as the distance or level between each category that is equal and static. For example, what is the average daytime temperature in Bangalore during the summer? Ratio variable is another type of continuous variable. This type of variable has only one variation from interval variable. The only difference is that the ratio between the scores given information regarding the relationship between the responses. A random variable is a variable whose value is a numerical outcome of a random phenomenon.
Probability distribution and its properties. We have the following properties. Number 1. Probability of each value of a discrete random variable is between 0 to 1 inclusive, meaning our probability of each random variable is between 0 to 1 only. If our probability is greater than 1, it is not a discrete probability distribution. Number 2. The sum of all probabilities is equals to 1. So when we will add all our p of x, it should be positive 1. Example, determine whether the distribution is a discrete probability or not. For our random variable x, we have 2, 4, and 6. And their corresponding probability is 1/2, 3/4, and negative 1/4. As you can see, we have negative 1/4. So this is not a discrete probability distribution. Now, example number 2. Our x random variable is 0, 1, 2, and 3. And their corresponding probabilities is 0.1, 0.3, 0.4, and 0.2. Let's add our p of x. It should be equals to positive 1. Let's add them. 0.1 plus 0.3 equals 0.4. 0.4 plus 0.4 equals 0.8. Plus 0.2 equals to positive 1. Therefore, this is a discrete probability distribution. Another example. A mother is giving birth to a twin. Let P denotes the number of boys. First, list all the possible outcomes of getting a twins. So we have boy boy, boy girl, girl girl, and girl boy. So we have for B, we have 0, 1, and 2. And the probability of getting 0 boys is 1 out of 4 since we have only girl girl. Okay. And the probability getting 1 boy is 2 out of 4 since we have boy girl and girl boy. And the probability of getting 2 boys is 1 out of 4. So we have boy boy. And we will add all the p of x. 1/4 plus 1/4. 1/4 plus 2/4 equals 3/4 plus 1/4 equals 4/4 equals positive 1.